Welcome to the EPG Pathashala program, which is a UGC program in the lecture series in computer science. This is the 8th module for the course compiler design, and the module is titled Lexical Analyzer Generator. We have so far seen how to define patterns using the automata, non-deterministic finite automata, deterministic finite automata, as well as using a regular expression. And we know that the pros and cons of defining it using DFA, NFA and RE, and then we also looked at how to convert one to the other just to utilize the faster string matching capability of your deterministic finite automata. So, you can use either a regular expression or a DFA. This is what we have seen so far, but this is extending this work. We are going to look at what is called as the lexical analyzer generator, which is going to be the tools involved in doing a lexical analyzer. The learning objectives of this module are to know about lex, JLX, etc., and how to design a lexical analyzer generator. That is going to be the primary objective of this particular module, and to understand the basics of the lex tool, because we are going to design the lexical analyzer generator using this lex tool. So, therefore, we should also understand the basics of the lex tool. Why should I go for a tool? Okay, why not go with a traditional and conventional deterministic finite automata or the regular expression itself? I think this question has already been looked upon in the first few modules, where we said that the phases of the compiler can be broken into two parts. First one is the analysis part, next one is the synthesis part, and in the analysis part typically it is going to be target independent, but it is source dependent. It depends upon the source language. So, therefore, where there is a commonality among languages, we can actually use a tool to actually define a pattern which is going to be common across all programming languages. Okay. Therefore, it is a good idea to go for a tool rather than starting it from scratch. Starting from scratch is again difficult, okay, because that is the functionality of lexical analyzer is it should basically improve, it should be simple to design and it should have a higher efficiency. So, therefore, we go to the aid of a tool, so that starting from scratch will be difficult. Therefore, to avoid this difficulty, we normally resort to a tool, and we resort to a tool by defining patterns and cater to a programming language. So, this language, which is actually defined by Lex, is actually a rule based programming language, where rules are defined, and then using those rules you can actually define your pattern, and once the pattern basically gets matched, you will be in a position to get your final tokens, which is the job of a lexical analyzer. This is done by a tool. This is what we have just now seen, and a lexical analyzer generator basically is a tool, and the standard tools which are available are the Lex, the Flex and the JLex. So, both Lex and Flex are C programming versions, whereas JLex is going to be a Java version of Lex. So, these tools are Lex and Flex are part of the Linux operating system itself. It comes with it. So, you can once you have installed Linux on your machine, you can directly start using this particular tool. Now, this Lex and Flex, JLex, all are tools. They are also programming languages, but they come under the category of rule based programming languages, where you will define rules to do what is called as this pattern matching. So, whatever we already know as defining patterns and then matching against an input string, that is basically done with the help of this particular tool. Now, how does this tool basically work? This is the overall flow of the lexical analyzer generator. Your input source program will typically be a .l extension file. Okay. Now, you have a Lex compiler, because I already said Lex is a programming language. Okay. You have a Lex compiler, and this Lex compiler takes this input programming, this input.l file, and it is going to generate what is called as a lex.yy.c file. It is going to generate a C file. Now, once I have a C file, I know that I can run it through a C compiler, and then I can basically generate my output using my a.out. When an input string comes into picture, I can execute it using the C file, and then I can generate my token sequence. So, input we have you already know C programming language or C++ or whatever programming language, every programming language will have its own extension. Now, according to that, the Lex program basically you have a .l extension. So, you have a Lex compiler here again which comes part of the Linux operating system. So, Lex compiler will compile the .l extension and it is going to convert that into a .c extension. So, it is called as the typical file it generates is lex.yy.c. This is a typical file which is generated whatever be your input. So, it is going to generate lex.yy.c and that is given to the C compiler which is going to generate a.out. I mean it becomes a typical C program. So, once you have a typical C program, you can basically run it through a C compiler to generate your output sequence. Once you have the C executable, you can give some data in your input stream and whatever data you do, depending upon whatever logic you have written in your .l file, the corresponding tokens will basically be generated. So, we will have examples here, we will see one by one. The Lex program typically consists of 3 parts. This is going to be a .l file. Okay. The initial, it has got 3 sections. First one is called as a declaration section. Next I have a translation rules and the third one is actually called as set of auxiliary procedures. Now, the double percentage which is available between declaration and translation rules and the double percentage is which is available between translation rules and auxiliary procedures, that indicates end of the declaration part and beginning of the next part. Similarly, the one which is available between the translation rules and the auxiliary procedure indicates end of translation rules and beginning of auxiliary procedure. So, that acts like a delimiter to separate the sections of your Lex program. So, a Lex program typically consists of 3 parts. So, the declaration, translation rules and auxiliary procedure. To distinguish the declaration from the translation rules, then you have this delimiter as double percentage. Okay. Once my program encounters double percentage, it knows that it is entering the next section. Now, what goes into the declaration part? What goes in the translation rules? What is going to be in your auxiliary procedure? So, let us before we actually get into that, let us see what it does to match some character. Okay. So, this will typically be part of your translation rules. Okay. Now, /n indicates new line, this we already know. Dot is a meta character that matches any character except new line. Star basically is the same star which we already know, the clean closure operator, meaning that 0 or more copies of the preceding expression. Plus basically means again the positive closure which is 1 or more copies of the preceding expression. Question mark is a special regular expression operator, this also we have seen, which means 0 or 1 copy of the preceding expression. Then this cap indicates is the beginning of a line, okay, and dollar indicates end of line. A or B, this is the same operator which we already know as A or B, and AB plus example is 1 or more copies of AB together. So, AB plus basically means, I think I have discussed this in one of the modules already. So, it is going to be AB followed by AB followed by AB, it is 1 or more copies, and A plus B within double quotes basically say literals, okay, and within the pair of square brackets it means it is a character class, a group of variables or group of information within that particular pair of square brackets. Now, these are some of the patterns which are basically used as part of your Lex program. Okay. Certain things we already know, that is we know what is a star, what is a plus, what is a question mark and what is a /n. /n is new line, we already know that. These meta characters are basically defined as part of the, one section of the translation rules. Okay. Now, what do I mean by those is what I have basically given here as part of matches, but this is basically used to define the pattern for your Lex program. Okay. And we also have dollar indicating end of line, A or B the same thing, and within the pair of square brackets you have what is called as the character class grouping. Now, declarations, this is the first section of your Lex program. Typically here I am going to use delimiter, okay. A delimiter basically is given by /t or /n. WS word space basically means delimiter plus, meaning that one or more delimiters will constitute your word space. I can have double tap to indicate space between words, or I can use a /n to indicate that I am going to get a new word after this basically. So, one or more combinations of this delimiter is what my word space is. So, I am defining here some declaration where delimiter basically means, delimiter indicates, it corresponds to whether if I encounter a tab or a new line, that is my delimiter. And what is a word space? Typically delimiter is used to separate out words. WS indicates word space, which is delimiter plus, meaning that one or more delimiters will basically constitute your word space. And letter basically means what? Letter basically means anything within this particular character class. So, if you remember that, we also had an example here where we looked at within the character class, okay, this square brackets is character class, and that is exactly what I am trying to tell here. So, letter basically means within the grouping A to Z, any one, anything, this will qualify for the declaration letter, that is what it basically means. And digit is 0 to 9. So, anything which is available from 0 to 9. So, I can also use a hyphen, which means that from 0 to 9. So, it is a sequence. So, 0, 1, 2, 3 etc. up to 9, that will qualify for the declaring digit. And I am defining what is called as an identifier. This example we have already seen, but we are just using this part of a Lex program here, which is letter followed by letter or digit the whole star. So, we know that of course, this is a Pascal declaration, it should begin with an alphabet. I can have any number of alphanumeric after that. So, that is what it basically defines here, letter followed by letter or digit the whole star. These are my some examples of the declaration rules, okay, declaration information. Now, on to translation rules. Now, translation rules will basically have an action, okay, a P1 and an action, that is a pattern and an action. Now, if this pattern is going to be occurring, what action should I basically perform? Okay. So, for example, if I encounter a /n, that is a pattern. If I encounter a /n, what do I do? That is my action. Okay. So, I have to write rules in the translation rules section, which is the second section of my Lex program. The first section is declaration. So, in declarations, what do? I simply define how am I going to define the patterns. Okay. So, the patterns are defined in the declaration section. In the translation rule section, I have the pattern and the corresponding action that has to be taken if I have a pattern match. Okay. So, you can have more than one pattern and you can have the corresponding action for every pattern. So, how many ever patterns you have to have a corresponding action also as part of it. You can also have the same action for multiple patterns, but you have to define patterns here. So, P1 or P2, or I can say P1, P2, same action I can simply copy and write it there. Example, if, return if. So, what is the pattern here? If I have a sequence I followed by if, then I return this particular character in caps IF. Okay. So, this is what the IF is a keyword, we already know that if is going to be a keyword. So, this is what it is a simple example. Okay. I have multiple examples here. ID, if I encounter ID, what is ID? How do I define ID? I would have defined ID already in the declaration section. Declaration section, we have just now seen that ID basically corresponds to letter followed by letter or digit the whole star. Okay. So, if I encounter this ID means it is letter followed by letter or digit the whole star. If I see that pattern, what do I basically do? I will say YYLVAL is equal to install ID of parenthesis. This I am going to call this function install ID and assign it to the variable YYLVAL, and then I do return ID. So, I can have, what is this basically infer? I can have multiple statements as part of my action. So, I have two statements here, one assignment and one return statement. I can have multiple statements as part of my action. That is what basically this conveys. So, if I encounter ID, I have to assign YYLVAL as a return value of install ID, and then I can also do a return ID statement as part of the function. Okay. Then I have what is called as auxiliary procedure. Now, auxiliary procedure is actually not mandatory, but it can be added as part of your Lex program. Now, typically in the auxiliary procedure section, you will have the main. You have the main which is corresponding to your C main. Okay. Now, this is an extra procedure, that is what is we have 3 sections as we already know, the declarations, translation rules and then auxiliary procedure. Now, what will this do? If you remember just now the previous case, we have called this function install id. Now, typically this procedure will be used to install the lexeme whose first character is pointed to by YY text and whose length is YY len, and this is put into the symbol table and return a pointer there too. Now, this is a standard procedure. So, which is this YY text, YY len, I think these are, you can actually refer to some material where this YY len, YY text are typical standard functions which is part of your Lex program. Okay. So, you have YY len, you have YY text, you have what is called as YY parse, you have YY error, you have unput, input, so many functions are available as part of your Lex program itself. So, you can use any one of the available functions here. So, this is what it basically does. So, install id, you have to write whatever you want to, whatever you want the program to do basically. So, that is going to be available as part of the auxiliary procedure. Now, auxiliary procedure will anyway have a main. Okay. Main is a default function in your auxiliary procedure section. You can also have additional information. Now, typically what happens is we will do this YY text etc. in your main itself. In that case, this may not be required. So, depending upon your requirement of sequence of output tokens, I can use anything. Let us take some example here. I can also write this separately and can be combined basically. Now, what does this do? So, I have this is my declaration section. I am defining a variable called as num lines and assigning it to 0. It is an integer variable. Okay. And then I encounter a double percentage. So, I know that I am entering the next section which is going to be the translation rules section. Now, what does my translation rule say here? /n, this is my pattern, and what am I doing here? I am doing an action here. What am I doing? I am simply incrementing this num lines variable by 1. I am doing a plus plus num lines, which means that once I encounter a /n, I am incrementing my number of lines counted by 1. Okay. And that is it, I am not, and once I say a dot, I put a semicolon, and that is going to be basically end of it, double percentage, which means I am entering the next section which is going to be auxiliary procedure section. Now, in the auxiliary procedure section, I said I am going to have a default main, that is what I have here, which is going to call this YY lex. This is a default function which is typically called as part of your main. And what does this do? This also does a printf number of lines is equal to %d num underscore lines. How does this program work? Let us just take a small look at it. Now, this is your .l file, call it as a.l. Okay. You run it through a Lex compiler where you will compile it as lex space a.l space lex.yy.c and you will compile it. Once you compile it, you will generate a lex.yy.c. Second line, if there is no error in your code, it will go for a command prompt. In that case, what do? You simply say cc, you compile it as a C program, cc lex.yy.c, and then once you do an a.out, you will be prompted to enter some lines. Okay. So, you will enter some lines of text here, and then once you do an end of line, it is going to basically semicolon is going to be your final terminating point. So, once you enter semicolon, it is going to say okay, end of input, therefore, it is going to count how many lines you have basically entered. Again, this is not the only way to do it. I can do this in multiple ways. I can read it from a file, okay, and then count how many lines this file has basically got. Okay. Anything is basically possible. So, the next example, okay, now what does this do? Int nchar n word n line. Okay. You are defining 3 variables here, nchar, n word and n line to count the number of characters, number of words and number of lines. Now, what am I doing here in the second section, double percentage, so second section. So, in that case, what do? I look at /n. If I encounter /n, what do? I have to know that I have to increment my line number by 1 as well as I have to increment my number of characters by 1. That is what I have done as part of the action section here. Okay, space alone is required. So, When I have a pattern here and I have a action here, separating the pattern and the action, I have to basically give a space. Okay. And what does this do? It is a cap or a slash t or a slash n plus. This is my word space. I know slash t slash n is my word space. Okay. If I encounter that, it means what? I have crossed one word. So, in that case, I am counting my number of words by 1, okay, and number of characters will be n char plus equal to yy len, which means what? Number of characters is equal to number of characters plus yy len. So far whatever you have encountered, so yy len will give a the length of the text, okay, yy text. So whatever is there, that will be incremented and that will be stored in number of characters. Dot, I also increment the number of characters by 1, okay, n char plus plus. So I will also increment it by 1 more. So this is my pattern. So I am incrementing my word count as well as my character count here. That ends my translation section, and on to the third part, which is the auxiliary procedure section. There what do? I simply call yy_lex and I am simply going to print %d slash t %d slash t n char n word and n line. I am going to print all the 3 variables here. Of course, you have to initialize here, all those things are mandatory. This is just a example. It's a, I haven't initialized here, so it's a simple example here, okay, and then return 0 just to complete your code, okay. Now this is what I said. We have seen some functions so far here, which talks about yy_lex, yy_len and so on and so forth. Now what does these functions basically tell you? Now yy_lex, basically it's a call to invoke lexer and it returns a token. So that is definitely mandatory as part of your lex program, okay, just to invoke the lex compiler. And then yy_text, it's a pointer to a matched string. So typically where will the string get matched? It gets matched in my pattern, okay. So that pattern, if it matched, yy_text typically points to the matched string, okay, and yy_len will give you the length of the matched string, okay. And we also look at yy_lval, which is a value associated with the particular token. Now what values can a token basically take? If it is a constant, it can take the constant value itself, okay. If it is going to be a variable, it is going to take identifier and so on. And yy_wrap, this is again going to be a normal default functions part of your lex compiler. It simply wrap up, that is return 1 if it is done and 0 if it is not done. That is, once your program is finished, it returns 1 if there is nothing more to process, and it is returning 0 if it is not done with processing. I also have yy_out and yy_in, which is typically the output and input file of your lex program. And begin condition, echo, so these are basically other functionalities, okay, which is switch start condition and write match string, etc. Now this is a C version. So lex and flex, basically I can use the same terminologies and I can use the same program to get your C version of your lex program. Lex is a programming language, it's called as a tool, okay, and it's a rule based programming language, okay. Now you have a lex compiler which is going to compile this lex program and convert it to what is called as a lex.yy.c file, and that is compiled by a C compiler to generate your output, executable output, and whatever you give as input, that will be tokenized by this C executable. Now there is a Java version also, which is JLX specification file, which is got 3 components again, user code, this code, it's a copy directly to a Java file. So the user code, whatever you type, your pattern match, etc., that gets copied directly to a Java file, and then you have a double percentage again indicating end of this particular section, and then you have the JLX directives, which is defining macros, state names, etc., and again a delimiter. Then you have the lexical analysis rule. So it is just changed, the information is basically changed in the JLX specification file as compared to your typical C lex program. So here rules comes at the end, their rules as part of the second section. Here if you look at it, the user code is at the last in my C file, whereas here it is in the first, and the directives, which is in the preliminary, the first section, now it comes at the second, Okay. So, there is just a slight change in the way you write the JLex specification file as compared to your C Lex file. Okay. So, this again regular expression action, again the same rules whatever you have done, slash n, your square brackets, your dot, your star operator, all those things can basically be applied here also. Okay. Now, this how to break an input to tokens in the JLex specification file. That is what we are trying to look at, and what action should you do when a token is getting matched. Let us take this example here, import java underscore cup dot runtime, which has got double percentage and then percentage cup here, and then the next section where I am initializing a counter variable to 0 and then I am closing it here. So, percentage end of value system dot, this is my C Java code here, line number is equal to plus line counter, okay, return new symbol, symbol dot EOF, end of file. So, the same example whatever we talked about in C is applicable here also, okay. Only thing is the way in which you write is going to be different, okay. And this is again counting new lines, new line is equal to slash n, again delimiter, and then new line will be you increment the line counter, and then the same example of encountering how many lines. This is what we basically look at. So, Java and C versions both are exactly same only. It is just that how you define and how you write your auxiliary procedure using Java or C is basically different. So, this is the example which we saw earlier. So, this can basically be modeled using what is called as your Lex program. Okay. So, it returns ID. Now, this returns ID if you could remember. Okay. Returning ID is done as part of the C program itself. Okay. Now, to summarize what we have seen as of now, we have looked basically at the Lex, Flex and JFlex, where Lex and Flex are C versions of your Lex program and JFlex is a Java version of your C program which has got 3 components. So, all you have to write is declare some variables, initialize them basically in your first section, second section write pattern and write actions that matches a particular pattern, and in the third section call the appropriate functions so that the pattern is matched and then the action is basically taken to give you only a sequence of tokens. Rather than going with the construction of a RE and an NFA, this basically is going to be much more convenient and much more simpler. So, this is part of the second module, which is next module, which is the parser. So, we conclude this module with this summary.